Hello, we are the Quackers, and we are presenting our idea, the Risk Surveillance Technology for the IP Hackathon 2021, which is a modern solution to help tackle active shooter situations. So the first step is to identify the problem, active shootings, and how can technology be used to address it. Here is a graph showcasing the active shooter situations by location. Here is another statistical graph showcasing the rampant increase in active shooter incidents. As can be seen, such incidents have rapidly increased over the decade and continue to grow, highlighting an obvious problem that needs a solution. The next question that arises is, what is the current system in place and what are its limitations? Well, the current system that is used to tackle such situations is inefficient and focuses on the hope of borrowed time, wherein the victims have to rely on either hiding or running without being aware of their surroundings or the location of the shooter within it. This poses a threat of encountering the shooter while trying to escape. Here's where the risk surveillance technology comes into effect. It is an autonomous, closed-loop surveillance system that identifies and tracks the live location of an active aggressor in a public or private setting using closed-circuit television cameras or CCTVs. But why should someone consider using RST? The first reason is minimal hardware. You see, RST is a software that can be run on most day-to-day computing devices and requires little investment in terms of hardware, which implies that companies should be able to easily run RSTs and implement them with their current hardware and software infrastructure. The second benefit of using an RST is that it plays a more active role in terms of protecting victims from attackers in active shooting situations by seeking and broadcasting the latter's location. And finally, the reason of safety, as RST provides a safety net to ensure that communities are able to defend themselves in situations of active shootings and that fatalities can be reduced as much as they can. But how does RST work? The first step is that video footage from surveillance cameras is processed through a supervised learning algorithm which detects suspects bearing an unconcealed weapon. As soon as the same is detected, step 2 occurs, which is notifying the security authorities about the presence of an aggressor. Upon such a notification, the system then either triggers the automated warning if a gunshot is heard or waits for the security authorities to trigger it manually. Finally, step 4 and 5 is that the ideologies behind the two patterns, that is the cause-effect analysis for video content and online semantic analysis by text embedding, are used to track the live location of the aggressor and inform the public through the PA system, which such announcements can then be used by the public to accurately determine where the shooter is and make decisions accordingly.
Let's now address the application of intellectual property in our product. The patents we've used in this technology are number 1, the cause-effect analysis for video content, and number 2, online semantic analysis by text embedding. So the optimization used in our patent basically allows us to retrieve more data while also being computationally efficient. So the algorithm we're using unsupervisedly is capable of grouping events from a video and convert it into visual words, which in a simple sense means that it's able to make sense of what the aggressor is doing. The pre-trained model will not require any computational power in real time, meaning that the application can be run with existing hardware frameworks. One more further thing to note is that the word vectors generated by the system can be perceived as unstructured text, which means that we can use online semantic analysis upon this text using a neural network, and we can generate a stream of words using an LSTM that can then be used to make an announcement on the PA system. The unsupervised component of this patented algorithm will help us identify some structural features in the language and help us improve our generation process. It is further noteworthy that this system certainly offers computational efficiency as well and is an improvement upon the conventional neural network architecture. Let's understand the market potential for this product. The education sector of the security equipment industry is a mere 20%, but that by itself is $2.7 billion in revenue, which is certainly quite significant. And the forecasted growth rate is around 1%. So while it isn't rapidly growing, we need to understand that the education sector isn't the only sector we need to be concerned about. We can also apply our product in the commercial sector, which accounts for around 40%, and the potential in that market has not been tapped significantly by any other products yet, which means that our product has a great head start in this region. That being said, we are highly optimistic about the future potential for the growth of our product. Thank you.